Hello there, everyone. My name is Crazy Caleb, and welcome to Hell again. Today, we're going to be taking a look at Mineswapper. So this is the way the Mineswapper looks. This is a KTANE module, by the way. And what we have here is we have a series of different things we're going to be looking at. Excuse me. So what's going to be happening here is that we have to pay attention to what's on the board right now. We have a 6x6 grid of tiles. And in this case, some of these tiles are going to have a series of different options. In this case, there's going to be empties, which is going to be represented by the simple number. And there's going to be numbers, but they have a mine on them. In this case, this sort of 8-pointed background. In this case, it's pretty obvious. It's a mine. So what our goal is with this module is that each tile has a digit and an LED and may or may not have a mine on it. In this case, we have a couple of these here. What these numbers mean is that in the 8 spaces around each tile, or in this case, in some cases, 3, 5, based off of whether it's on the corners or not, the adjacent tiles around it, we need to make sure that we place all of these digits so that the amount of mines that surround them are equal to that number. In this case, if we take a look at this 2 right down here, its bottom right LED in this case is green because of the fact that there are only 2 mines adjacent to it. This grid does not loop around, by this 6x6 grid does not loop around, by the way. It's very important to note down. But in this example here, as we can see, there's only 2 mines adjacent to this 2. This 2 has been lit up. There are only 2 mines adjacent to this 3. That's not gonna light up. It has to be exactly all of these numbers. And this is what's gonna make this mod a very, very tricky module. This is exactly why it is indeed 50 points on Twitch plays, because it is a nightmare to do, and also a nightmare to figure out what the hell the solution is. There is a lot of guessing and checking to this module. However, what I would like to show you is some of the very efficient ways to do this. Get as much information as you can without guessing and checking, and then we sort of force it a little bit with the numbers that have been given to us. So now taking a look around, there are not many mines actually present on this module. That is one thing that's very important to note down, is the fact that there are not many of them present, and there's actually quite a few 5s that have no mines present on them. So this means that we're probably going to have a lot of mines that are close together, as well as a lot of these 5s that are going to be essentially close together as well. So that's going to be one of the clues that we're going to be seeing quite a few spots that just simply are not going to be there at all. So let's figure out exactly what we're going to be doing with this. But first things first, let's also take a look at the outer edges of the module here. What these outer edges, in this case the columns and the rows, what these represent is the amount of mines that are going to be in each column and row, respectively. So what we have here is we have a series of different 3s and 2s. That means in this specific column, there's going to be 3 mines present in it. There has to be 3 mines present in it for the solution to work. And then there's some cases that might be encrypted in this case. In this example, we have a series of different spades, which means that they're going to be the exact same number. And what this is going to be based off of is this marked rows and columns. And each row and column is marked with the number of mines in that row or column, as I just explained. Some of the markings are encrypted, and what they will be encrypted in is they will be encrypted in all of the different card suits, in this case, spade, heart, diamond, and club. So what we have to do is we need to figure out the day of the week and the 6-hour interval in which the module was activated in to be able to determine those clues. And one other thing that's very important to note down is that sometimes if you happen to get sort of bugged cases where some of these edgework cases might be bugged for some reason, I'm not sure why that would be that case, but it's possible. What would happen here is you need to, there is one way that you can check and make sure that everything works as intended. And what that is this is going to be making sure that the columns and the rows, if you add them up together, in this case, the columns separately and then the rows separately, they both should equal each other. That's what they should both be equal to, and that's going to be a way that you can be able to tell, and which we will do in this example, and I'll do in just a minute. So let's take a look and let's see what we can figure out here. So let's actually figure out our markings here, so we can actually figure out how many are going to be in these columns and rows. So I'm actually going to set up our grid here real quick, 3 2 3 2, and then spade spade. First things first, my current day is going to be a Thursday, so it's going to be going down here, so we're going to be using this row. And now, as we can see up on the top here for these columns, what's going to be happening here is these represent the 6-hour intervals, and they use 24-hour time. For those of you who are familiar with time zones, this is going to look very familiar to you guys. It's a fairly easy module, which I would advise learning, by the way, because it's going to be relevant in a lot of cases. and also just easy to understand too. So this is going to be essentially midnight to 5:59 in the morning. This is going to be 6 a.m. to just before noon. This is going to be noon to 5:59 p.m. And this is going to be 6 p.m. to the 11:59 p.m. in this case. But it's currently 2:19 for me right now. This is going to be corresponding to this group right here, and this is going to be what's represented by these guys. So all we care about in this example is we're going to be caring about the spades. There's no clubs, there's no hearts, and there's no diamonds that we have to worry about. But each of these have a series of different things. Now, one thing that's very important to note also is that some of the symbols are themselves dependent on when the module became active, using year, month, and day as the format for the date, and hours, minutes, and seconds as the formats for the time. It's a bit particular, and in most cases, I don't even think you'll really see S's at all. There's like very rare. Yeah, you don't even see it in any cases. But that's just for the hours, minutes, and seconds. It's mainly going to be minutes, or month rather. But in most cases, you won't even really see that. But that's very important to note down. Let's make sure you know this. And some encryptions are the result of division operations. You will always round down with this result. So let's take a look. So the spade, what do we need to figure out for this? We need to figure out the battery holders for this. So how many battery holders do we have present on this bomb? It's going to be just one battery holder. So it's a 2 and 1 right now. So this means that these spades are going to be equal to 1. Okay, let's zoom in here real quick. So we have 1, 4, 1, 4, 1, 1. Okay. And now, what this is what represents our grid here. I kind of like to do this grid, and one of the things that's very important is that the way that I just did this here, you have to be careful with the spacing because you can go back, and for some reason it tabs out automatically. For those of you who are familiar with how Notepad++ works, if for some reason tabs out automatically, and I'm not sure why, just make sure that you sort of do this backing up movement. Just to make sure that you can't operate with all of the other spaces, because it's very important that you have all 6 spaces that you need in order for us to be able to use this efficiently. And the way that I'm going to do this is, the way that I like to mark this thing up is it's going to be X for mines, and it's going to be hashtagged for the numbers, in this case, no mines, or empty spaces. I'm going to mark empty. So that's going to be what we're going to be using. So now, let's take a look and let's see how we can actually determine this thing, because there's obviously some clues that we need to figure out, and there's going to be a couple things that I want to pay attention to. So our first clue is going to be using the serial number. In this case, it's going to be clues to a particular solution. Valid solutions may be found that do not satisfy the following conditions, but there is always one that satisfies them all. So let's take a look. Excuse me for a second. So let's take a look and see what we need to do here. And actually, first things first, we need to get our serial number. This is very important that we do this. We have a 976 Foxtrot November 9. Okay, so now let's take a look and let's see what happens here. So what's going to be happening here with our serial number is we're going to start from the top left corner of the board and make a number of moves for each character in the serial number from left to right. So we're going to be starting in the top left, but we're not going to count the top left as 1. In this case, we're going to start at the top left position, and then, for example, say if we had 5, we would count 1, 2, 3, 4, 5 over to this tile. That's the way that this works. So let's take a look and let's see what we need to do here. So we have, if a character is a 0, move to the diametrically opposite space on the board unless this is the first character of the serial number, in which case stay in the top left corner. Now, if you happen to have a 0, obviously, as you just said, if you're going to stay in the top left corner if it's the first character. However, if you happen to be in like the middle of some position and you don't know how to do the diametrically opposite space, the way that I recommend doing this is, because of the fact that this is a 6x6 board, there is going to be an even amount of spaces that's going to be able to do diametrically. So we have we have our horizontally opposite and we have our vertically opposite. In this case, is represented by these like large lines in the middle. And what's going to be happening here is that if you happen to say, for example, I'm at this 2 right here, and I need to do a diametrically opposite because I happen to be on the same exact character. What I like to do is the way that I think about it is that you're doing essentially both the horizontally opposite on top, and then you're also doing the vertically opposite. And what I'd like to do is I like to do one after the other. So I do, for example, vertically opposite. In this case, I go over to this 3 over here, and then I do horizontally opposite. In this case, that takes us over to the 3 right here. So this 2 is diametrically opposite to the 3, and the 3 is diametrically opposite to the 2. And that's going to be the way that you're kind of going to do diametrically opposite. It is rare for it to happen, especially since zeros are not the most common thing, but it can happen, and you need to make sure that you know it. So let's take a look. If the character is a non-zero number, move that many spaces in reading order. If the character is a letter, move as many spaces in reading order as the alphabetic position of the letter. And if the space you stop at is already assigned, we're going to move down the board until you land on an unassigned space, wrapping around to the top of the board if necessary. So the way this happens, if you happen to have a specific tile that you landed on beforehand, you're simply just going to go down that exact same column. Since there's only going to be 6 characters in the serial number that we're going to be using here, this already means that there's no way possible for it to be the exact like coming into a loop essentially. It is possible to get all 6 of them in the exact same column, though that is highly, highly unlikely. But it does prevent it from actually being able to, from actually happening here. So what's going to be happening here is that we're going to then assign the space to be a mine if the position of the character in the serial number is odd, or empty if it is even. The way that you can simply do this is simply visualizing it like this. So we obviously have our positions from left to right being 1, 2, 3, 4, 5, 6, like so. And what's going to be happening here is that the first one is going to be a mine because its position in the serial number is odd. Then the second one's going to be an empty. And the third one's going to be odd, so it's a mine. Then the fourth position is even, it's going to be empty. So it's going to be mine and then even. And then as you can see, it's going back and forth. So in this case, 1, 3, and 5 are going to be our mines, and 2, 4, and 6 are going to be our empties. And this is going to be represented by the position of the said character. And as you can tell, and as you can see here, we have a me. So that's going to be the way that this looks. So let's get right into this. So we need to figure out our mines that are going to be guaranteed. These are guaranteed spots to be mines, and these are guaranteed spots to be empty. That's going to be the key thing here. So let's take a look and let's see what we can do here. So we're going to be starting in the top left corner, and in this case, we're going to be starting with a 9. So we're going to be starting with a 9, and the way that I like to do this is I like to count by 6s. It's much, much easier to do this. And in this case, all digits are going to be equal to what they count as, except zeros. So we're going to do 6, 7, 8, 9, and our first mine is going to be in the delta 2 position. So we're going to do delta 2, and that's going to be our first mine taken care of because it's the first position, and its position is odd. So in this case, that's going to be our first mine. Next up, continuing from this exact same position, in this case being delta 2, we're going to count 7 spaces now. So we're going to go 6, 7, and our first empty space is going to be an echo 3. Okay. So from echo 3 now, we're going to be counting 6 spaces. We're going to go down to this position here, and that's going to give us an echo 4. Echo 4 is going to be our second. Next up from echo 4, we're going to be counting a foxtrot, which is a 6. So we're going to be counting down 6 spaces more. Very interesting indeed. And now, this is going to give us our second empty space. This is going to be an echo 5. Okay. And now, let's take a look at our next one. So from echo 5, we're going to be counting 14 spaces, because November is 14, so we're going to do 6, 12, 13, 14, over to alpha 2. Alpha 2 is going to be our last mine, and 9 is going to be from alpha 2, 6, 7, 8, 9, over to a delta 3. We have not had delta 3, we've had delta 2, so this is going to be our last empty space. Delta 3 is going to be our last empty space. Okay, so now with these clues, let's start filling in our grid here, and let's fill in what we know. So remember, X is working the mines, and the empty is going to be the hashtag here. So let's take a look. So delta 2, in this case, is going to be right here. Delta 2 is going to be our first mine. Echo 4 is going to be down here. And then alpha 2 is going to be our next mine. Okay, these positions are going to be our mines, and our empty spaces are going to be echo 3, echo 5. Echo 3 is a hashtag. Echo 5 is a hashtag, and delta 3 is going to be our hashtag, delta 3 right here. Now, immediately, one of the things that we can already rule out is the fact that this is a 1 here. And we already have our mine taken care of in this column. This means that the rest of these guys are going to be numbers. We know that for a fact because of this clue. So that is going to be perfect. And now, another thing I said I was going to do here real quick is I said I was going to make sure that we both had the exact same amount of these numbers here to make sure that these are both true in what they are. So let's count up the columns first. In this case, we have 3 plus 2 plus 3 plus 1 plus 1. In this case, is going to equal 10. Now, 3 plus 2 plus 3 plus 2 plus another 2, excuse me. I don't know why I failed there. And now, so that's going to be equal to 12. So the column's total is going to be adding up to a total of 12. Now, do the rows equal the exact same amount? In this case, we have 4 1, so it's going to just be 4 plus 4 plus 4, and that does indeed equal 12. So this means that this is going to be the exact numbers that we're looking for. It's a nice little way to make sure that something is not bugged, for example. And if it is, you can obviously fix it and figure out what's wrong with it. So let's take a look and let's see what else we need to do here. Because there's one last little clue that we need to be able to, that is not mentioned in the manual at all, and this is where I would advise you guys to know exactly what I'm talking about here. And it's going to be this formula, and it's very, very important that you know this formula by heart, and it's going to be, I actually will leave it in the description of this actual video, and it's very, very important that you have this formula memorized, because it's very, it is just the ultimate deciding factor. I don't know how Diffused and Username figured this out. I wouldn't know it for the life of me. They probably looked through the code, but it is 8 times the total number of mines, minus the total value of 36 digits, of all 36 digits on this module, is going to be equal to, we're going to zoom out here a little bit, equal to 5 times corners, and then we're going to plus 3 times edges. That is the formula. And I do not know how you guys figured it out. If you guys want to let me know how you guys did it, that would be nice. But essentially what this is going to give us is a very, very important clue. Whether we have anything in the corners. That's going to be very, very important to note down. So it's going to be 8 times the total number of mines, minus the total value of all 36 digits added up together, and then equals to the 5 times the amount of corners plus 3 times the amount of edges. So first things first, let's actually figure out this left side. This left side is very easy to figure out, and this is essentially going to be what we're going to do here. So we have total amount of mines, in this case being, let me make sure my voice is on too. Yes, it is. The total amount of mines is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In this case, it's going to be 12 times this by 8 is 96. So 96 is going to be our first value here. Next up, we have to add all these guys up, so it's going to be 1 plus 2 plus 5 plus 1 plus 1 plus 2 plus 2, 3, 2, 3. I'm going to just start simplifying things. Plus 9 plus 7 plus 5 plus 5. That's an 8. That's going to be 10. That's going to be 5. This is going to be 3, and this is going to be 5. So now what we have here is we have a total of 79. So it's going to be 96 minus 79. 96 minus 79, in this case, is going to give us a total of 17. Okay, now what we need to do with this is we need to take a look at one real quick thing. So, we have 17, and this is going to be equal to 5 times the corners plus 3 times the edges. And what you want to be able to do here is you want to start just plugging things in. That's going to be the way that this works. So now let's take a look and let's see what we can do here. So, in this case, let's start plugging things in. And obviously, one of the things that's going to be the clear factor of just determining whether whether this thing is correct or not is because there's only going to be 4 corners here. You're only going to have the range of 0 through 4. And in this example, it's obviously going to be a couple options here. So, it's not going to be 4, simply because of the fact that 4 times 5 is going to be 20, and that's going to be over here. So we already know that 4 is out of the option here. We also know that 0 is out of the option because 17 is a prime number, and it would not be any multiple of 3. It has to be an exact amount here. So we know that 0 is out of the question here. Now, let's take a look and let's see what else is possible. 3 times 5 for corners is not going to work because it's going to be 17 minus 15, which in this case is going to be resulting in a 2. 2 is obviously less than any multiple of 3, so this means that is not going to work. So 3 is out of the option. Same thing with 2 times 5. 5 times 2, in this case being 10. If we do 5 times 2, in this case being 10, what we result in is we get 10, so 5 times 2 being 10, but we subtract, we get 17 minus 10, which results in a 7. And 7 is not any multiple of 3. So this means that our last number has to be the possibility of 1. And the way that we can determine this is we do 5 times 1, in this case is 5. We subtract that, 17 minus the 5 is going to result in 12. This 12 is a factor of 3. So if we divide by 3, we get 4. And what this gives us is there's going to be 1 mine in a corner, and there are going to be 4 mines on an edges. And the edges, what I mean by that, are going to be these little 4 squares on every single side. So there's going to be a total of 16. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep. So it's just in that outer ring, except it is not the corners. That's essentially what that is. So we've determined now there's going to be 1 mine in a corner, in one corner. The rest will be numbers. And we've determined that there will be 4 mines on an edge, on the edges. That's going to be helping with us for later on, especially because we can then rule out a lot of the options here. So now, this is where we begin with the fun part. And by fun part, I mean absolute hell. So this is the only possibility for this to happen. It is a very important formula to memorize because there is the possibility of you getting, for example, 4 corners. That will be quite nice, and that's going to help you with a lot of calculations, especially with trickier examples. But in this example, I think this is actually really a bit of an easier one because of the fact that we know there's going to be a large grouping of mines somewhere along the lines. So we need to figure that out. But essentially what we need to do now is we need to figure things out. So let's try and figure things out. And I'd say one of the things that we need to notice is also the fact that the mines themselves, they cannot have too many people around them. They cannot have too much around them. And also another thing that's very important to note down is there's actually not going to be that many around them in the first place because of the fact that the rows are going to be really limited here. There's going to be 4 in this row and there's going to be 4 in that row, but they're really not going to be attached all that much together. So that's going to be a very important thing to note out, which actually gives me a couple ideas, and I have a couple hunches in mind. One of the things that I want to take a look at is I want to focus on this 3232 basically, and it's going to be focusing on completely this side. And I want to focus on trying to get rid of these 5s somehow, which might result in, for example, putting mines here, here, and here, and then filling up this little section right here, here, here. And then what we have here is we have a series of different numbers popping up into place here, and this could potentially lead to a couple of 5s. But we need to also be careful because of the fact that we want to make sure it's going to be exactly 5 and not 6s because we don't have any 6s. So this means that this is not going to be the correct location. I believe it can be here. Yes, I can see several different options where these 5s can go into place here. And let's actually start placing mines in here. Actually, I want to start doing this because let's start interacting with it. So we have 3 5s, yes. So we have a 5 here that has 5 mines adjacent to it, and it's not a mine itself. In this case, we have these 5 mines right here. 5 right here, it's these 3 mines and these 2, 5 mines, and we have 1, 2, and a 1, 2, 3. This is exactly what we're looking for, which means that this is going to be our 1 for this row. And if this happens to be true, what we can already figure out is we can start eliminating these options right here with the 2. So let's hash this out because of the fact that we already have 2 mines already in place. So hashing you out and hashing you out. So we've already determined quite a few options here. We need to be careful with what we do here though. And we've also determined that this is going to be a number as well. This is going to be a number as well because of the fact that we've already taken care of the 4 here. This is going to be number, this is going to be number because of the fact that this column of 1 has already been taken care of by a mine right here. So this is going to be completely gone. And we've already determined a lot of the module here by guessing and checking. Now remember, we have, 96? It was 8 times total amount of mines. So 96 was a factor of what? Divided by 8. It was a factor of 12. We need to keep in track of how many more mines we have left so that we can split them up evenly here. So let's take a look. So we already have 9 mines in place here, and this means that we're going to be placing only 3 more in the module here. So we need to figure out these last locations for these 3, and this actually is turning out to be a really, really easy one actually. And I'm quite pleased with that. But this is going to give you an idea of how this is going to help you. We know for a fact that one of them is going to be in a corner. We know that for a fact. That's just one thing that we can guarantee. We also need to remember that we need to fill out this 4 edges. We've already done 1 edge right here, but we need to figure out where else we can put it. And I have a couple ideas in mind. Perhaps what we can do is we can perhaps do this and this, perhaps. Let's see if that works. That takes care of the 1 and the 1. And that takes care of 2 remaining that we needed to get rid of. However, this doesn't fill out the corner issue that I needed to take care of. The edge case. Because if we happen to put our last mine up in this top left corner, that takes care of the corner. That's fine and dandy. Oh, no, wait. I forgot about these 2 edges. This actually might be our solution right here. Because of the fact that we have taken care of the one corner, we have 4 mines on the edges here. We have 1, 2, 3, and 4. And what we have also done is we have also taken care and addressed these amount of 5s here. I believe this is going to be the solution. Do we have a 4 miner? That is the one thing. No, we actually don't even need to worry about that. So now, let's start placing this together, and I believe we actually do have a solution here. And what I like to do is I like to focus on the mines first. I like to focus on the mines themselves, but I do believe we have a full solution here, and I believe that this does indeed make sense with the mines that we are given to us. Let's try it out, because I believe this could be our answer. So let's start placing things in here. So first things first, we know our 5s. We know exactly where our 5s are going to go, and this is going to be going in this one area right here. This is going to be, yes, this way. So let's do 5, 5, and 5. Quite impressive how that all works out together, but it does indeed. Then what we're going to do is we're going to start placing mines here. This one is going to be a 2 because there are 2 mines adjacent to it. Do we have one? Yes, we do. It's going to be up here. Next up, this one is also going to be 2 because these 2 mines are adjacent to it, right there. Then what we have is a 3 right here. We have this one, and this one. That's going to be a 3. And this one's going to be a 1 because there's only this guy that's adjacent to it, and that's already placed in there. That's perfect. Next up with this one's a 1 down here, so we have a 1 over here. And I guess one other thing that's very important to note down as well is the fact that all of these mines have to be connected in some way, shape, or form. It wouldn't make sense that this X would be anywhere else because of the fact that there wouldn't be anything else connecting. If it was in the bottom right, for example, no mines would be near it. That would be a problem, and that would pose quite a difficult issue here. So let's take a look. So this is going to be a 1 over here. This is going to be a 2. We do have a 2 right here. This is going to be another 2 right here. This is going to be another 2. We do have a 3 here. This is where things might get a little bit concerning. And I'm actually getting a little bit nervous about this. 2, am I missing something? 2, 2, I'm missing a 3. And this is where things might not work for me. Let's put this, yeah, so this is exactly why this might not work. Because of the fact that there are not enough of the mines that we want to have here placed, we might have to mix some things up a little bit. So let's think about this a little bit more carefully. Perhaps what we need to do is, maybe we just need to swap these 2 positions. Maybe it's this corner that needs to go down here, and maybe it's this guy that needs to go up here. So let's try that, and let's see if that fixes anything. I think that shouldn't cause any problems. Make you a number, and make you the corner. It doesn't change the edges. That's perfectly fine. So this means that we would actually have a couple more 3s in place here so that we can instead place 2s elsewhere. That's perfect. That's, I think, exactly what we need right here. So let's place this 1 over here. Let's place a 2 down here. Let's place a 3 up top. Let's place a 1 down in the bottom left. Let's place a 1 over here. Let's place a 2 over here. Let's place a 3 over here. I think we have it. So what we have done here now is we have determined the correct solution. As we just saw, we had a couple options here, but we were able to figure out that the mines that were given to us were not able to work. So all we had to simply do was swap 2 positions. Now with this example, what we have here is we have these 5s. These 5s were a key giveaway, and the fact that there was 2 columns, there was 2 rows of 4, that already meant that they were going to be really, really close to each other. But now, essentially, all we have to do is we have to simply just start placing numbers around it. All we have to do is just place the numbers with the mines around it. In this case, this one's a 4, that's a 1, that's going to be a 3. We'll swap these 2 guys. This is going to be a 0, that's going to be a 2 right up here. This is going to be a 1. Let's get a 1 right here. That's 3. And as you can see, things are starting to come together. These zeros are also very obvious. Let's get these zeros down here, right down here. That is a 4. And we're very close. So this is going to be a 3. Is there an open 3? Yes, there is. Okay. There is indeed an open 3. And this last swap will solve the module. We have this 1 and this 3 here. There are currently 3 mines surrounding this square, and there's 1 mine surrounding this square. And just like that is a solved module. Now, this thankfully was a lucky example with this one. And it still actually was a little bit tricky, but what I was able to deduce was where things were going to go. I was able to have quite a few hunches, and it was really given to me. There obviously are much trickier examples with this module. I will kid you not. There are a lot worse examples that I've gotten that might not be so obvious, and in which case what makes this module so unpopular is the idea of the brute forcing. But in this example, I was able to figure things out really easily. Again, that's not going to be the way it is for everyone, but that is essentially how this module works. Remember this formula. This formula, I cannot stress enough, is of the utmost importance that you have to use this. It's I don't know how they figured it out, but it is very important in order to solve this module. But I'm going to leave it here. Hopefully this solving process helps you figure out some of the more logical puzzles of this. It is a little bit of a fun module once you get into it, though there is definitely a lot of tricky elements. And there is obviously that brute force element that makes this module so very tricky. As always, stay crazy, stay cool, and I will see you in the next one. Bye-bye.